One of the barriers when it comes to going back and studying math is variables. Variables is letters next to numbers. Once we get the X's in there with the sevens and everything, it feels very uncomfortable because it's what are these two things doing together? Well, there was a day back when we probably had recess and stuff like that, and maybe even nap time or whatever, where math looked like that. All the known things would be on one side and the unknown would be on the other. And we would go, what plus what equals what? And we would take the known things and we would put them together and we would figure out that it's 7. Algebra says, what if the unknown is mixed in there with the knowns? What if it was this? So we have a known and an I don't know that have to interact to get a known. So what we would want to do in that situation is get the unknown thing all by itself, just like we had it before, just like when we were doing, nap time and all the other stuff, that sweet math, where it was just figure out that thing. Well, that's cool when it's all by itself. So we need to get this thing all by itself. So the way we're going to do that is called isolating the variable. We're going to get rid of this 5. It's a positive 5. It's a 5 just sitting there. And the way we get rid of that 5 is subtracting 5. So 5 minus 5 is going to disappear into 0. Well, in order to be fair and equal, because we want to be fair and equal, whatever we do to one side, we do to the other. Now, this style math we used to do and we liked, was also stacked like this sometimes, where all the knowns were on top, all the stuff we knew was up here, and the question mark was down at the bottom. Well, that's what this math turns into. It just happens on the other side. We have to sort of make it happen. So 5 minus 5 is somebody hands you $5 and then takes it back. It all goes to 0. And then this unknown question mark comes on down here. And then we get to do that style math. Right here, 12 minus 5 will be 7. Now the one thing they do, and you know what they do, is we don't use question marks and we don't use blanks. We use a letter, and the letter is just X. X just means a number I don't know, and I may figure it out. Sometimes we do, sometimes we don't. It's just, it could be anything. But then if we solve for X, all we do is get rid of all the stuff next to it, do actual math on this side, and one by one we get rid of those numbers that are around the X. So I'm going to clear all this out and drop another one and hit pause real quick. I'm going to change to blue. So if it was X plus 19 equals 304. All I did was make the numbers bigger, so doing math on our fingers isn't that comfortable. So I'm going to retell the story. It was so much better when it was 5 plus 7 or something like that, when it was all stacked up like that. That was great. And 7 minus 3, that was cool. Algebra lets that happen, but we just have to make it happen. We want to isolate our variable. Or if you're into country music, we want our X's to be alone. That sounds like every country music song ever. So we just sing a song about, oh, I want my X's to be alone. They should be lonely or whatever. So we got to get rid of this, positive 19. Now, there's always going to be that question, is that a plus or is it a positive? Well, it's kind of both, because it goes with the number. As the story gets told, 19 more things get added to it. So they sort of are stuck to each other. But we can just look at them and go, okay, we got to get rid of plus 19. The way to get rid of plus 19, minus 19. And then to be fair and equal, we got to do it on this side too. Now on the side with the variable, the letter, all we do is artwork. We don't really do math on that side. plus 19, minus 19, bleh, it doesn't mean anything. And then our x comes on down here and the x is alone. And we get to find out with honest to goodness math what goes here. Now, there's a number that goes there. 304 minus 19 is an actual number. But more important than getting it right is seeing how this makes sense. That we want to get, just like we want to get everything back to this style math. So the unknown thing is all by itself. So what is 304 minus 19? 304 minus 19 is 285. Now I used my calculator for that because I have no shame. Because when you take the GED math test, you're going to be tired. Around 46 questions that are written in an intentionally distracting and fatiguing way, we are going to be tired. And 41, only 5 questions where we cannot use our calculator. Only 5. So if we get to use our calculator and we get down to the end of a problem and we think 5 minus negative 5, we're like, okay, I'm not going to use okay, that's cool, that's 0. And we get to the point where it's 6 minus negative 4, and we're like, I'm not typing that in, that's 2. Or 7 minus negative 3 or whatever, okay, that's 4. All of these are wrong because minus a negative is the same as plus a positive. So all of these equal 10. And adding and subtracting positive and negative numbers is such a it's like grinds the gears in your brain. But I mean, 5 plus 5 equals 0 looks ridiculous. 6 plus 4 equals 2 is ridiculous. 7 plus 3 equals 4 is ridiculous. But it didn't look so ridiculous like that. GED is amazing at writing questions like this. So have no shame. 7 minus negative 9. Can't do it in my head. I don't want to. Because somewhere in my mind, 7 minus negative 5, I feel like a 3 should be in there. But 7 minus negative 9, okay, let's do it. Did I say 7? I said 6. Should be a 2. Because 7 and 9 are 2 apart. 7 minus negative 9 is 16. Yeah, I was way off. So when it comes to memorizing stuff, we want to use our calculator as much as possible. So I'm going to draw one more problem, and then pause the video. Let's write it in blue. 3 times x plus 4 equals 19. Well, we just ran into a problem. The old-fashioned multiplication symbol looks too much like an x, and x's are something that is going to be used the most often. So we're going to have to change that symbol. So a times dot that's hanging in the middle there means multiply. And anything next to each other tends to multiply as well. There's tons of hidden multiplication in algebra, which is okay. We'll get used to seeing it. This is how most of these problems are going to get written, but I'm going to do the times dot for now. Okay, so I'm going to pause the video just for a second. Okay, so if we look at this real quick, we want to get used to this style of equation. It's called a linear equation, or it's two-step algebra, or slope and y-intercept. It is the #1 problem or equation or expression that shows up on the GED math test. So we have to be comfortable with it. It can be described as a 3-year-old kid. 3-year-old kids will walk in the room with any sort. They could say anything. They could be mad at something, whatever. If they're upset, if they bring a problem, the problem could involve pumpkins and kittens or who knows what, but it's generally always the same problem. It'll always come back to they wanted to get their way and they didn't, and then they're upset. So dealing with a 3-year-old kid sometimes gets a little bit aggravating, dealing with this kind of problem. gets a little bit aggravating. However, if you're the kind of person that can deal with a 3-year-old kid, you're the kind of person that can deal with this kind of problem because it's going to keep showing up. If we're trying to solve for x, just like before, we want the x alone. They call that isolating the variable. Smart math people do. So that means we got to get rid of the 3 and we got to get rid of the 4. This is where it's like country music again, getting the X's alone. Or you could think of it as like a bad 1991 movie with Steven Seagal called Under Siege, where you're going to save the hostage's life, and that's the super bad guy, and that's the henchman, and you know how it goes in the movie. You get rid of the henchman, so there's a final showdown with the big bad boss or whatever. But you're sitting there going, I got to take care of this dude, and then I got to take care of this dude and rescue the hostage. That is a dumb example, but at least it sticks in your brain a little bit. So we got to get rid of +4. Well, how did we do it last time? -4. To be fair and equal, we got to do it on both sides. These cancel out. 3x comes on down. 3 times x. I put the little times in x to remind us what we're doing. Then we do math, just like we did when we were a kid. You know, that fun math. So we are one step down. We're into the final scene of the movie. Well, the second to last scene when things go down. Plus and minus are negative. They're opposite each other. Not negative. They're opposite of each other. Plus this way, minus this way. It's like they're brothers and they just tug of war or whatever. This is multiplying. So we got to come up with the opposite of multiplying, which is dividing. And maybe they didn't tell us this in school, but a division symbol is just a picture of a fraction. In fact, it's a picture of a fraction that tells us how to divide things. We would just type in, if we have 2/3 and we want to turn that into a decimal, that's how you type it into your calculator, 2 divided by 3. So since this is 3 times x, in order to get rid of that 3 and it's upstairs, we're going to have to put it downstairs so we can cancel it out. And then just like over here, we did the opposite here. We got to do it on the other side. Whatever you do to the left, you got to do to the right. We got to do that. Now, I always draw this line a little bit too long. This cancels out. X is going to come on down. And the reason this line's a little bit long is because of this thing right here. What do we do with this? We divide down. All the math on that side goes in a downward direction. Now, there's 1 or 2 exceptions, but it is straightforward math, just like we did when we were kids, and that's how we type it into our calculator. Whenever we run into this style of problem, these steps we use every single. Okay, we're just going to do a very quick review of the 4 functions of fractions. And we're going to use the same fractions for all of them.
Okay.
So when we add or subtract, it's the same rules. Oh, that was bad. Let me redo that. There we go. It's multiply across the bottom and then sort of do the pitchfork like that. So we multiply across the bottom. And then we multiply that way. 10. Lift that sign up. We know what we're doing. And multiply that way. Add those together, whatever that is. Now we may have to reduce. We may have to do something with that fraction. Absolutely. Totally true. But it's technically right. And I want us to feel really firm with that. That if we do those steps, we may have to adjust it. It may not be exactly what is one of the answer choices. But those steps are rock solid. So that's adding. The only difference between adding and subtracting everything else stays the same. 3 times 5 is still 15. 5 times 2 is still 10. Minus comes up instead of a plus. 3 times 1 is still 3. And then this plops down there at 7. So that's how we want to feel about fractions now. Now, of course, it's going to get more complicated. Of course. There's going to be times when it's just like, what? And all these other things. But When we deal with this stuff, we can go, you know what? I'm learning to feel more comfortable and feel strong about this stuff. So I'm gonna undo all that. And now we're gonna do multiplying and dividing. Multiplying is the drag race, or if you watch Rebel Without a Cause with James Dean, they called that the Chickie Run, when they go flying off the cliffs. Two cars are racing, and all we do is multiply across the top, multiply across the bottom. So that's 2, and that's 15. So that is drag race. Well, and again, we may have to mess with the answer, but it's technically right, which is a wonderful feeling. I mean, there may be a better version of that, but that's fine. That's not what our job is right now. And we're just doing a quick review here. And now we're just going to do division. If we're dividing fractions, we say, man, I wish I was doing multiplying because multiplying's fun. It's a drag race, and math says you can. Keep.
Just flip it around.
Yep. Keep that the way it is. Oops. My 3's always look jacked up. Change that sign. So that's the C. Flip this thing upside down. So it's not Kentucky Fried Chicken. It's keep, change, flip. Now we do the drag race again. Keep, change, flip. Now we do the drag race again. So again, we may have to do, but it's technically right. So again, we may have to do. If they ever ask us to mix fractions and whole numbers, we'll write it like that, where the whole number and the fraction will be the same size, which is stupid. We're not going to do that because we don't discriminate. All numbers are fractions. If you have $7 in your pocket, if you have $7, even if it's a 5 and 2 ones, you have the value of 7 $1 bills. So every whole number, 21 is a whole number. It has a ghost 1 underneath it. So they should write this stuff like this, where the top numbers are matching. And then mentally we could go, oh yeah, there's a ghost 1 underneath here. So now it's back to multiplying with fractions, which is what we like. Drag race. So it doesn't matter whether you 21 over 4? Whatever the answer is, and again, we would have to change this around, but it's still technically right. Here we see multiplying or whatever with a whole number, whatever it is. We got to remember, I forgot it was a 5. We got to remember that all whole numbers are actual fractions too. We're all the same. And now it's back to just being a drag race. So those skills that we covered on doing fractions that way, they travel. They travel a lot of places.